Okay, hello, my name is Michael Downey and it's a great pleasure to welcome you all to the 8th AWRI webinar for this year's program. In this week's session, we look at cover crops in the undervine zone as a method for reducing reliance on herbicides while also improving soil health and productivity. But before I jump over to our speaker for today, some very quick reminders for the audience. To provide a comment or ask a question, please open the Q&A part of the webinar, type in your question and click to send it through. If you'd like to get involved through Twitter, please use the Twitter handle @_AWRI. The webinar is being recorded and will be available to view later this afternoon from the AWRI's YouTube channel. I'd also like to acknowledge Wine Australia for providing funding and support for AWRI webinars. Okay, so for those that have just joined us, welcome. Today's session is Vine Medication, the benefits of undervine cover cropping, and it's a great pleasure to introduce today's speaker, Chris Penfold. Chris has been a researcher with the University of Adelaide for nearly 30 years, and his research has focused on the enhancement of system sustainability through investigating non-chemical weed control, undervine management, and cover cropping systems. His most recent project investigated the use of suitable plant species to improve soil health and vineyard profitability. It's fantastic to have Chris here to share results from his work. So enough from me. I'll hand over now to Chris to get started.
Thank you, Michael. And thank you very much to Wine Australia for having funded this work, University of Adelaide for hosting it, and for you people for logging in and having the interest to be involved today. It's been an exciting journey over the last few years doing this work. It's been and it's really nice to get the interest that's been shown in the outcomes from it. I'd like to acknowledge my co-authors in this work as well, Melanie Weckert, Tom Nordblom and Mark Norton, all from Wagga, and Jake Howie, a pasture scientist here in Adelaide. So the topic today, vine medication, is a bit of a play on words. You'll get to see a bit more about why we're calling it medication, but how we might use plants to overcome some of the constraints that we might have from the undervine areas. So to get us started, a reasonably typical sort of a scene here, the way the undervine is managed with bare herbicide area. It's at Eden Valley, a very picturesque area. But there certainly is some issues with the use of herbicides in a regular basis on soil quality. It does upset the structure, largely because of not just the herbicides, but more so because we're removing the vegetation, which is should be growing in that undervine environment, we believe. By taking out that vegetation, we are having a detrimental impact on the soil structure and its associated biology and reducing carbon levels. There's also other issues which you'll be all pretty much aware of. I think that with application costs, OH&S costs, no OH&S issues with some of these products. There's a lot of resistance out there these days to the herbicides, and there certainly can be issues also with the use of pesticides and access to some markets and so on. Also just the image that we're portraying when we are removing all the vegetation of the undervine area, and people think a bit about is that best management of our soil when we do that. And for many people, I believe that there's an individual preference to probably use less herbicides as well so they can get around it. How do we get around it? What are the options? So generally is, cultivation. It's a costly exercise. It's going to potentially damage the vine roots as well, and we're going to lose organic matter in the process. Grazing and mowing, well, they're only partial mechanisms, I think, for overcoming those weed issues. We still get an amount of water loss or transpiration coming from the weeds or plants that are growing underneath the vines. So alternatively, we can use straw, which is quite a fantastic mechanism for overcoming weed issues. It does smother the weeds very effectively, but it is costly as well, about $3,000 a hectare or so if you can access it, and droughts aren't good for that. Otherwise, coarse fraction compost, another excellent product in these situations, but also quite expensive too. There's certainly issues that have been determined from people like Rob Murray, Cam Grant, Mike McCarthy and co, who have done work on the vineyard subsoils, and particularly these duplex soils where you get a sandy, loam textured topsoil and then a quite a heavy clay underneath, and that clay is often very, very high strength, which means that the roots have a lot of problems with penetration into it. So we get very low infiltration rates and probably very poor water use efficiency as a result of that. So they determined that, you know, in order to try and improve these soils, things like gypsum or ripping are pretty much out of the question, because we can't effectively get infiltration or get the gypsum being down through the profile very quickly, because we can't get in there and cultivate. So roots of other plants are going to be a much more effective mechanism, and particularly roots from plants that are growing over the winter period when the soil is softer, so they can open up the soil with their own roots and produce those micro and macro pores that the vine roots can then access when they're growing actively over the summer period. So here's a scene which wouldn't be seen as being strange to many of you, where we're getting ponding on the soil surface with the sealing of the soil. So we get poor infiltration of that soil and probably poor water use, with evaporation being fairly severe in the wrong weather conditions. We can overcome that fairly quickly just by the growth of cover crops. In this case, it's medics, which have been grown. They've mulched down after they've senesced at the end of their growing period in spring, and left this lovely thick mulch on the soil surface, and those root channels going down through the soil, enabling that water movement quite readily. Other work by people like Belinda Rawnsley from back in 2010 found that there was very low microbial activity in many of our soils, no matter whether they're cultivated, biodynamic permanent sward or mulch in that left-hand side graph, well below what the expected regime would be for a healthy level of activity. So from the constant removal of vegetation is not doing what we would call best practice management for our soils. So other work by people like Brian Hughes from Prime Industries, who surveyed 14 vineyards out in the Adelaide hills, and we can see on the left-hand side where he's looked at a grassed undervine row. We've got about 3% organic carbon there, compared to the third column across in the bare undervine row, where we're down to less than 2% carbon. So by the constant removal of this vegetation, whatever it might be in the undervine area, we are certainly having a negative effect on soil carbon levels, and that is really detrimental to the health of our soil. We need the carbon there to drive the biology, which will help drive the structure and improve our vine roots' capacity to access the moisture and nutrients in the soil. So this is the trial site at Nuriootpa, one of several we had going. Typical bare soil, undervine. The other options are with the straw mulch, as I mentioned, or we can put out compost, all with their associated costs though. So can we do it instead with growing plants, which will both compete against the weeds and also provide improvements in soil structure or soil health in general? And here we see the trial site with clovers growing on the right-hand side, the straw mulch on the left, and then medics on a bit further down on the left-hand side. So the project aims were to reduce the need for repeated herbicide use in that undervine zone. In the process, we would improve soil health, hopefully. We would grow plants which are beneficial to the grapevine, potentially leading to improved yields and quality. And in the same breath, we would also improve vineyard profitability and ecological sustainability, all going well. And we seem to achieve most of those. We had trial sites at Nuriootpa Research Station up in the Riverland, at Eden Valley, a higher rainfall site there, and Langhorne Creek, which is about 350 mil rainfall, but applying about 3.5 megs of water per year. So again, you know, all quite different from one another. We applied 10 different treatments, starting off with the triticale mulch, applied at about 50 tonne to the hectare. Casbar cocksfoot, which is a perennial grass, but it's meant to be in a dryland situation, it's summer dormant. But we found out that that certainly doesn't work out in the vineyard situation where we're applying irrigation, so it remained green all year, which is rather disappointing. We had wallaby grass in there, a fairly short-statured one, geniculata. It also stayed green for most of the growing season. We had an annual grass in there. I was looking to use barley grass, but that wasn't available as seed, so we used silver grass, rat-tail fescue, bit of a non-event though. We then had several medics in there, So treatments 5, 6 and 7 all had medics of varying forms. They are all pasture legumes, have been well received in the pasture industry for many, many years in southern Australia. They work very, very well in our neutral to alkaline soils, self-regenerating, so they produce lots of seed to be able to bounce back in the following years, whether it's within the cropping system or completely pasture. And also produce a lot of symbiotically fixed nitrogen as well. In treatment 7, we mixed that with some annual ryegrass to try and get the benefits of both the legumes and the grass root system, which is fantastic for improving soil structure. We then had a couple of perennials again, fescue and strawberry clover. They had subclover and the herbicide control. The treatments were sown just with a little vineyard cedar from, in this case, from New Zealand, towed by a quad bike. Just sowed it with one row, within about 20 centimetres of the vine butt, both sides of the row. So it was a fairly quick and easy seeding system. We'll talk a bit more about that later on. The important thing is, though, to be able to sow it shallowly and to make sure that the insect pests don't take over in that first year. So some of the results, so here's some of the silver grass on the left-hand side, doing pretty nicely. In this case, ryegrass, 2016, doing very well. There's medic underneath that. The ryegrass is utilising a lot of that nitrogen, though, which has been produced by the medic in the past and is growing very happily, which would be a concern to many people, I would imagine, seeing cover crops like that at that time of the year. But you really have to hold your nerve because they do work out well. In this case, wallaby grass. This is a Caspar cocksfoot, looks very similar to the ryegrass, also doing very nicely, but that did keep on growing. In this case, it's a medic with ryegrass, barley grass, and so on mixed in with it. That's a substantial crop of medic, though. A pasture farmer would be very happy with that. It's about 6 or 7 tonnes to the hectare. And here we have Mintaro subclover. And there we have strawberry clover growing underneath the vines. You can see the vines are all doing very nicely, as well as at the same time as having that very green strawberry clover. This is 2016. And we had some bit of extra moisture that year, which enabled it to also do pretty well. So part of this work was trying to look at ways that we can reduce the need for herbicides. So using these plants that we're growing to actually compete against other undesirable plants, often called weeds. And I won't go into this in detail, but essentially, if we're going across from the left-hand side, our triticale mulch had nothing growing there. It was very effective at suppressing weed growth. The cocksfoot also suppressed weed growth very well. The wallaby grass, a bit to the lesser extent. If we go across to the right-hand side, the medics, which have grown very nicely, and the clover, have all suppressed weed growth very well. There's hardly any weed intrusion there at all. This is in October 2016. If we go to May the following year, and even despite that being a fairly wet summer, there's still very little in the way of weed growth that's occurred over that period. It's just those perennials, which are the columns which you can see evident there. The others are just have mulched down, and that mulch might be helping suppress weeds. Whatever the mechanism, it's worked fairly well. One of the things we're trying to do here is try and improve soil structure, and one of the ways we're trying to get a handle on that is looking at penetration resistance. And here at Nuriootpa, we can see that on the right-hand side, the herbicide control, so it's been kept bare all along, is the greatest level of resistance. It's up above the 2,000 kilopascals limit, which is recognised as being about the maximum that roots can handle to actually penetrate through the soil. Any more resistance than that, then the roots can't cope with it. So as we go down to the left of that, that control on the right-hand side, we see that those annuals have all managed to reduce the resistance considerably, and over to the triticale mulch on the left-hand side, which is that's probably the best of all. So here we're looking at, I believe, largely improving the soil's biology through having roots there, which are then improving the structure of the soil, which is then reducing that resistance occurring. The big concern, I suppose, is with growing these undervine cover crops is their use of moisture. And when we have a look at this graph. So this is from flowering time in 2016, and it's been duplicated in other seasons as well. We see it, the depths down below 15, 40, 70 and 100 centimetres, and 4 treatments which we were logging with gypsum blocks, bare soil on the left hand side, then straw, medic and the cocksfoot. And we can see 15, 40, 70 and to a lesser degree 100, those the medics in the straw in particular are taking out a lot of moisture. Now this is flowering time, so that they have all powered away. The medics have grown maximum amount of biomass. They've set seed. They've been dragging on as much moisture as they could access to do that, and they've completely dried out the profile to the maximum that the gypsum blocks will work to at 500 kilopascals. So that is fairly dramatic, and it's probably not the sort of thing that most of you would like to see. But remember, we'll see a little bit further on, but this is actually the highest yielding treatment the medics are. So come harvest time, and we've got very high tensions coming from the cocksfoot and particularly the bare soil at 40 and 70 centimetres, to a lesser extent 100. But the medics, for some reason, and we don't understand why, this is part of the reason why we're keeping this project going for another couple of years, is that the medics, despite being the highest yielding, have still got quite a bit of moisture left in the profile, as you can see at that 70 centimetres and 40 centimetre depths, and we just don't quite understand why that is. Whether we're getting better infiltration, as we talked about before, through those root channels, and we've got better access to the moisture from the vine roots, we don't really know. But it's pretty interesting. This might be part of the reason for it. We've managed to improve soil carbon. If we compare the control, which is the second column from the left, at 1% carbon, which didn't change at all. And it's the same as the triticale mulch. The mulch doesn't actually do much for increasing carbon because it doesn't have the nitrogen there to do it with. But if we compare that control to the, say, the ryegrass scimitar, the second one from the right-hand side, which is one which we're looking at as being something which might be adoptable by many of you, that's a 19% increase in carbon over 3 years, which is quite remarkable. I mean, in this case, we're not removing any of that carbon. We're not grazing it with sheep, or we're not baling it for hay or any such thing. But it's very impressive. And that's the sort of thing which is going to help out that soil health considerably, is that carbon improvement. If we have a look at the yields then that have come off here, I'm just concentrating on the Nuriootpa site. We will talk briefly about the other sites as we go through. In 2016, so certainly a drier year that year, and the triticale mulch was certainly provided the best yield of all, and significantly different from any of the others. But that costs $3,000 a hectare. We can go down a little bit in yield, and the ryegrass and medic treatment, which is very similar to the control, for $300 a hectare, we're getting fairly similar sort of yields, and we're not having to worry too much about weeds. And then we go further down to the left, and we see those perennial species have really brought the yields back considerably. The one on the far left had prima gland clover in it. I believe that the reason for that yield suppression is potentially allelopathy coming from the coumarins produced in the gland clover, which are really there to suppress red-legged earth mites eating them. But it might have also suppressed yields in the fruit. In 2017 at Nuri, we see on the right-hand side, the medics were very strong performers again, along with the mulch, and the control herbicide was way down. So in that case, that's about a 30% increase in yield, which at $2,000 a tonne was about a $5,000 increased return, just in pure revenue terms. So that was quite considerable for that season. In 2018, we didn't get the same significant differences there. There's a bit more variability over the site for some reason, but we still had that trend towards the medics on the right-hand side being very strong. For some reason, wallaby grass is up there as well. But we certainly we're trending towards a higher yield anyway than the herbicide control once again. We've done some wine assessments coming out of the 2017 vintage, just had them assessed in a couple of wine shows, not necessarily prestigious wine shows like the Gawler show, and also the Australian amateur wine show from down here at the Waite. But I'm sure the judges know what they're talking about. And there we see that we don't seem to be having any deleterious impact anyway by having these cover crops growing underneath the vines compared to the herbicide control, except possibly with that Caspar cocksfoot on the left-hand side having a lower score. Something which is pretty important to you guys is gross margins, how we're getting on for this in dollar terms. Tom Nordblom's an agricultural economist over at Wagga, one of the co-authors of this paper. And we can see here from his simulated gross margins that we are with the medic on the right-hand side compared to the control, third column from the left, about $1,600 per hectare improvement in gross margins. This is using 2 years worth of data, but he's simulated that over a much longer period of time. So it certainly does look promising from that perspective. That's about a 30% increase. So that's fairly useful. The other sites as well, we had about the same sort of gross margin increase at Eden Valley. Langhorne Creek was about 15%, and Waikerie, there was actually no improvement in gross margins there. To just look at the yields coming from the other sites, at Waikerie, the cocksfoot was fantastic at suppressing some very obnoxious weeds there. Things like prickly lettuce and thistles and fleabane and so on, which all grow fairly prolifically in that environment. And they didn't get a look in where the cocksfoot was growing, but it also reduced yields by 20%. So we haven't had the opportunity, unfortunately, to be able to work further with that as to how we might be able to manage that, possibly without that sort of yield suppression. The medics didn't impact on yields at all, though. At Langhorne Creek, medics plus and minus ryegrass were equal to better than the straw mulch and the control. Certainly had benefits there. And at Eden Valley, the medics also improved the yields. That's in the higher rainfall environment. And it's very fertile soil there too, but they still had some benefits. So how do we implement this? If you are keen to look at adopting it, it's really difficult to do it organically, unfortunately. There's a large seed bank there to work with already, and to get control of what's growing underneath the vines to start with, before you can plant these cover crops, is pretty difficult to do. It'd be nice to be able to do some more work in that area, and I'm sure there's scope for that. We do have some ideas on it. But otherwise, we spray out the germinants coming from that any autumn rain. If you can do that nice and early, spray them out, give yourself a clean seed base to work for, and then sow it with minimal disturbance, so you're not generating the environment for another weed germination. So sowing with minimal disturbance disc is the way to go. Sowing early in April is desirable, getting these things away when the soil is still warm. Depending on the seed bank, you might need some selective herbicide control in that first year until these things get established. And you can have fairly slow emergence and growth there in that first year because they're really working in a fairly sterile environment. They don't have that biology there to support them, so things can be fairly slow to begin with. This photo, courtesy of Treasury Wine Estates, shows a modification they've done to their seed of just putting a disc on the outside of a John Shearer so that they can use their seed box with every other run except the outside blocked off. And there's a bit of spring tension there to keep the disc in the soil. So there's a fairly easy modification for most people to be able to do in their workshop. Importantly, though, you need to have that disc with a ring around the inside of it with a bit of flat steel to minimise the depth that it can go to. So we only want to be sowing it at about 1 centimetre maximum. So that's pretty critical. Otherwise, if it's too deep, you just won't get emergence. So you need to select varieties to grow well in the area. Speak to your local agronomists. Try and get short season varieties of those pasture legumes, ones that are going to senesce fairly early. You can, I believe, we haven't tried it, but I can't see any reason why you shouldn't be able to mow and throw from the mid-row if you have a good selection of species in there, which you believe would be suitable, particularly those medics and maybe some of the grasses as well. But no perennials, best keeping those out. Present knowledge would certainly suggest using those regenerating legumes and in our case ryegrass, but other grasses will probably work as well. But make sure they're annuals. Be sure to inoculate those legumes, and a lot of the seed does these days come pre-inoculated. because there's not going to be so much in the way of rhizobium in that soil. It hasn't had the legumes growing there. So in order to get the benefits from this, you do need to have active rhizobia working to generate that nitrogen on the legumes. There's no need to try and sow everything underneath that undervine area. The legumes will spread quite prolifically and fill in that space pretty quickly. And don't go any deeper than that 1 centimetre. There's certainly issues. There can be issues with pests. Medics are they can be consumed by some of the pests like red-legged earthmite and lucent flea and aphids. So keep an eye on that. But if you get them in early, before things get too cold, you can beat their emergence from their diapause state. So the earlier the sowing, the better, and get them started. Sow at fairly hefty seeding rates to give yourself a better chance. There's no need, and this is the great joy in these things, there's no need, unless you happen to have a really dry year like this year. But once you've got these things established, you shouldn't need to apply any herbicides for them to senesce. Just let them do it of their own accord. They'll do it in this time of the year. We've got medics senescing now. Most of them, it's all set seed and it's ready to die off. And it does provide a lovely mulch there when it does so. But if you do have a really dry year, once you've got these things established, you've got a big seed bank and you've felt the need to try and conserve moisture, you could spray it out and know that they will then come back the following year from that seed bank. So in conclusion, I suggest that as with many of these biological processes, the cover crops don't always go to plan. It's a bit like an expanded version of your own backyard, and things don't always work out like you intend. But be patient, persevere, and you'll certainly get to reap some benefits, I would hope. Don't expect them to be pure stands of the sown species. There will be some weed intrusions, no doubt, just with seed blown in from elsewhere or some in the seed bank or whatever they may be. But hopefully they'll be weeds which you can accommodate rather than having to try and remove. They might just come up one year and then be outcompeted in following years. Once these medics get well established, you can be producing maybe 2,000 plants a square metre, which is very hard for any other plants to try and get a foothold in. They compete really, really well. In fertile soils, you might not see the same benefits in some of these less fertile soils, where the legumes and the grasses are really working, I believe, to improve that soil health, and hence the impact on the vines as well. I just find it incredibly satisfying to transform this bare soil into what we would like to see as being a living medium, and which the vines seem to be appreciating as well. And we don't need to be using that herbicide cart too much more, hopefully. So with that, folks, I'd like to thank you all very much. I'm sorry I've had to go through it fairly quickly. There is a full final report on the AWRI website, and Michael will be providing you with those details. If there's any questions, I'm more than happy to answer them and follow it up with you. Thank you.
Okay, great. Thanks very much, Chris, for running through the results of those trials that look very promising. We're going to move from here straight into a Q&A. So Chris will stick around for a little while. If you've got any questions for him regarding this topic, please start sending them through now. Quick reminder, if you're not familiar with how to do that, just open the Q&A button on your webinar toolbar and type your question and send it through. So we've got a couple of questions come through already here, Chris. A couple of easy-ish ones to start with. Over how many years were the trials conducted?
So we started planting in 2014, which was not a particularly good year. It was fairly dry then, and so we didn't get the growth nor the seed set which we wanted. We did have to replant some of it in 2015, and then it ran through until middle of 2017. But we have kept those couple of sites going, Nuriootpa and also Langhorne Creek, and we are going to be doing some more work with those, in part looking just at what I was suggesting to you before, getting a better handle on how that change in soil health might be benefiting the vines, and particularly the moisture side of the equation, what is happening in the soil, which is enabling those vines to perform as well, despite having an incredibly dry profile at flowering time.
Okay, great. Thanks for that. In one of your earlier slides, I think it was around the establishment of cover crops, you spoke about oxidation of organic matter. Can you just explain exactly what you meant by that one?
So oxidation of organic matter occurs with a combination of temperature, moisture, so warmer temperatures, then getting moisture on it, so this can happen on the soil surface, but also within the soil as well, so it can be stimulated by tillage, and so the microbes will then enjoy that environment, so they've got the food source, which is the organic matter, they've got reasonable temperatures to operate at, and they've got the moisture there as well, so putting the three of those together, and so the soil microbes then enact upon that organic matter, going through a mineralization process in which they can convert that organic matter into mineral nitrogen, but in the process they're also giving off carbon dioxide as well. So over time that organic matter is converted into CO2 and the levels of organic matter in the soil are reduced.
Okay, great. Thank you for that. Another question here. How does the undervine cover crop affect fertigation practices? Does it require a greater rate of fertilizer to be applied?
We haven't varied our fertilizer input into any of these treatments. I would suggest, as far as fertilizer application goes, though, you're going to be able to, well, depending on where you are, I mean, if we're talking the riverland, sunraysia type environment, the capacity for fixing nitrogen with the legumes is somewhat reduced because here we're reliant on rainfall over the winter period. So the amount of biomass that we can produce in the legumes, which has a direct link to the amount of nitrogen that they produce, is going to be reduced. Whereas in the wetter environments, we can produce large amounts of legume biomass. And there's a rough equation, which is for every ton of legume biomass, dry biomass that is, produced, there is about 20 kilograms of nitrogen produced. And so some of those sites, we're producing 5, 6, 7 tons of legume biomass. So we're producing about 100 kilograms of N in that area underneath the vines. So that is going to, I would suggest, largely suppress the need for any nitrogen addition. And all of these sites had adequate P levels, so there's certainly no need for phosphorus addition. Some of the other elements would have to be determined through tissue analysis, but it's very unlikely, I believe, that these cover crops are going to be modifying or requiring any additional nutrients. If anything, you're going to be reducing that nutrient requirement.
Okay, there have also been a couple of questions around irrigation and whether cover crops affect the wetting patterns, and if there was a need to provide greater irrigation.
As I was suggesting, that's certainly an area which we are going to be looking at with the continuation of this project, as to how soil moisture relations might change. We haven't investigated any changes in wetting patterns, but I would expect that as a result of producing these macropores and micropores from the roots and their associated mycorrhizae and so on in the soil, that our wetting patterns might expand rather than being the teardrop shape. They might go laterally a bit more. I don't know. It's a good question, and I guess it's also going to depend a huge amount on the soil type that we're dealing with as well. So no, at the moment I can't really help you on that. Sorry.
No problem. Some more to investigate there potentially. Is there any consideration given to humidity in the fruit zone generated from the different cover crops?
It's not something which we have tried to measure. And I guess the humidity increase, if there was any, and I doubt whether there's going to be anything substantial there, but it's only going to come from those perennials which are still growing over the fruiting period anyway. And I'm not recommending the perennials as a desirable cover crop unless you are really wanting to try and drag back your yields. In some cases, in those wetter environments, they could work quite well, but I still would doubt in our fairly dry environment that there's going to be much in the way of humidity increases there, just because of the fairly small area that they're taking up compared to the greater area of the vineyard. And they are certainly things like the clover and fescues and that sort of thing, they are all fairly low growing as well. They're not tending to be up in the canopy so much. With that cocksfoot, I have started trying to see if we can reduce its moisture requirements by giving it one mow at this time of the year. And so we've certainly reduced its height and probably reducing its transpiration as well. Whether that's having an impact on things like humidity, we don't know. So.
Were there any attempts to establish the cover crops organically, or is that just too hard?
We did have one site which was an organic vineyard and tried hard to get these cover crops established there. It was really difficult. The major problem is that most of these cover crops have reasonably small seeds, and so hence the shallow sowing depth. It also means that their energy in those early stages of emergence and growth is not that great. So their capacity for competing against other plants is not so great either. Once they're established, and once you have a large seed bank of these preferred species, then it's quite different. But trying to get an organic vineyard into a state where you can grow these smaller seeded plants is pretty difficult. We did try hard. We did try also with some larger seeded cereals and so on as well. But yeah, it was tough. You know, you'd start off with a nice clean seed bed, and very quickly those the endemic species would grow away just as quickly, if not quicker, than what had been planted. So yeah, it certainly does come with its challenges. But I would suggest though that something which we weren't able to try is that the idea of the mow and throw. So with the mid-row, where you can then manipulate your species composition somewhat more by a bit of cultivation if required, and mowing and that sort of thing, if you were able to generate a good stand of particularly medics in the mid-row and let them grow through to maturity, and then mow and throw the seed from there to the undervine area, so you've got a huge amount of seed to deal with, then potentially that would add to the species mix in that undervine area and provide you with some longer term benefits.
Did you find when the annual legumes died off that the weeds took advantage of the bare soil? And in your opinion, is a permanent species more preferable?
Yeah, it's interesting. The permanent species, once they're established, are certainly much easier. Well, is that the correct term? They're more reliable, as in they're always going to be there, no matter what the season. Whereas the medics, grasses to a lesser degree of annual form, they are somewhat dependent on the seasons as to how well they will bounce back. Some seasons with an early autumn rain, and they will get away really quickly and well, have a later break to the season, and they might try and get away, and might get eaten by insects or whatever. But I don't see that as being a huge issue. So over the summer period, where we had a lovely mulch laying on the surface from these species which had senesced, and we got very little in the way of weed growth coming through in that summer period, which is probably also assisted by the amount of canopy and so on which are growing there as well, which are providing shading, so that, it's not such conducive conditions to weed growth. That does change though when you go to places like the riverland, where the things like the legumes, those pasture legumes which we've grown, have done a great job of producing additional nitrogen to the soil, which is then providing additional nitrogen for the weeds. And so unless you have competition over that summer period, then the weeds do very, very nicely. And so there are other practices required. And I think if one is to pursue things like the medics in the riverland, we would probably need to be able to come through with a herbicide application in that sort of late spring period, just to knock the emerging summer weeds before they get a good stand. And then, you know, things like shading and so on would hopefully keep them fairly well contained over that summer period. But those sort of things that need to be explored further. So in general though, getting away from the riverland into the slightly wetter environments, we didn't have much in the way of weed problems over that summer period at all. It was quite encouraging.
Did you notice any difference in disease load in the vines, and what about frost as well?
Yeah, disease load, it's not something which we monitored as part of the trial, but those people whose vineyards that we were accessing for this trial and who we're very much indebted to, they were keeping an eye on things, and I mean, they're going through their standard sort of spray program anyway, and there was at no time was there any increase in disease that they could see during the period of the trial. So that was, I guess, very, very pleasing as well. Regarding frost, well, that's an interesting one. The frost is such a difficult one to get a handle on. We've just had a frost up in the Barossa about 3 weeks ago, and looking out over the trial site, and it did get frosted, particularly in the lower areas, but across treatments, probably because it's such the treatment area is comparably small compared to the larger area of the vineyard, and it's really difficult to see any differences between where we've got the cover crops and the control over a larger area, whether it's going to make a difference. I really don't know. It's a big question, and I just don't have those answers. I'm sorry.
No problem. Thanks, Chris. There's a comment from someone in Southeast Victoria. Oxalis regularly spreads on cleared undervine areas, but dies off in early spring. Would cover crops be suitable in this scenario?
Yeah, an interesting one. The Oxalis has sort of been promoted, and I've talked about it in the past as well, as being, if you're going to have a weed, well, it's probably one of the better weeds to have in, and it does compete against lots of other less desirable plants over the winter period and does die off in spring, as you suggest. I just feel though that we can do better than Oxalis with these other species that we're suggesting, the legumes and the grasses and so on. The Oxalis doesn't contribute very much to the soil. The vines seem to be quite happy with its presence there, but it'd be really interesting to be able to conduct a trial comparing Oxalis with what I've been suggesting here in the way of legumes and grasses, and to see if we get benefits from the latter. I would suggest we probably would. The Oxalis, about the only benefit coming from it is that I can see anyway, is that it does loosen up the soil structure as those contractile tubers retract into the ground in springtime. They do certainly open up the soil, which is probably good for infiltration. But aside from that, there's not much in the way of contribution except for looking good.
Can you just speak to the sowing method again, Chris? Someone here has asked, would it be one row of seed no more than 1 centimetre deep and about 25 centimetres off the vines. Does that sound about right to you?
Yeah, thanks for the question about the sowing. And I'm sorry, I've had to sort of plough through things pretty quickly there. So yes, the desirable, or what we have used anyway, is just 1 row of seed each side of the vine, and I'd like to try and get within about 20 centimetres of the vine trunk. I'd sow it about 5 kilometres an hour just with that single disc in the soil, and around the perimeter of the disc, about 1 centimetre in from the outer perimeter, is welded a piece of flat steel, so that that sits on top of the soil and prevents the disc from penetrating any more than that 1 centimetre. And then the seed is dropped in just in the little crevice created by the disc, and then covered over with chains, press wheels, that sort of thing, depending on the soil moisture and so on as to what sort of covering devices that you use there. And so it is a fairly simple process once you're set up for it. And the seeding rates that I've been suggesting, roughly 20 kilograms of legume seed, maybe around 20 kilograms of grass as well. If you're using grasses in there, it becomes a fairly cost-effective sort of an operation as well.
If you establish the cover crop and next year weeds are coming through, would you suggest hand removing or spraying?
Yeah, depending on the scale that you're operating on, I suppose, too, as to whether you're looking at hand removal or spraying or whatever. I mean, for trial purposes, we've used the whippersnipper quite effectively, but that's not the sort of thing that you're going to be able to use on a larger scale. There are some other mechanisms, though, besides necessarily spraying. I mean, there is certainly capacities for taking out if you've got some undesirable broadleafs in amongst the grasses. Jaguar works well, but you'd be needing to go for a pure stand of grasses then, because the Jaguar will take out nearly all the broadleafs, and so you couldn't have the medics in there. So often that need for selectivity is reduced, because we are often looking at mixtures. Otherwise, if you're going for a mostly medic stand, which is fine, and you've got a lot of undesirable grasses, and there are selectives that you can use there as well. The other way that you can do it, and it's something which we did develop at Roseworthy, is a sponge wiper on a retracting mechanism which bounces around the vine butts, which we mounted on the front of a quad, but could be mounted on a tractor or whatever, which then gives you vertical separation from the cover crop which has been sown. So if you have undesirable plants which are growing well above the cover crop, you can use this vertical separation and non-selective herbicides to take that out. Otherwise, you might be looking at undervine mowers, which you have to raise up and just have it skimming across the top of the cover crop to take out some of those other weeds as well. So yeah, I mean, if you don't start off with a clean seed bed, you certainly could have some challenges there. But probably over time, things would sort themselves out, as long as you can get a large seed set of the desirable species to then get away the following year and try and outcompete things. But if you want any more information about that undervine sponge wiper, please get in contact and I can send you some pictures and talk to you about it.
Okay, I got a question here from a New Zealand listener who's in a subtropical climate. How do you think medics and or ryegrass would go in that sort of a climate?
I've seen medics and ryegrass growing quite successfully in southern Queensland. They work wonderfully well for a lot of the farmers up there, so I would be suggesting that it should be fine. Yeah, I wouldn't be constrained, I don't think, by being in the subtropics at all.
Still got a few questions here. Would you still recommend laying down a layer of compost into the undervine area to increase organic matter and assimilable nitrogen?
I don't see the need for it. The results that we've been getting here would suggest that we can achieve those same objectives just biologically with the plants that we're growing, and for considerably less cost. I would have liked to, would have been interesting to have had compost in the trials as well as another control to compare against. We didn't have that, unfortunately. It was just the straw and the herbicide control. I mean, the compost is not going to do you any harm, certainly, but I would, I guess, challenge the need for it. It hasn't been something which we've seen as being a requirement as a result of this work.
Comment here from someone: I'm fighting glyphosate-resistant ryegrass. What are your thoughts on seeding Scimitar Medic and spraying out resistant rye with Verdict? I'm in Langhorne Creek.
Yes, getting the Medic going is fantastic. I guess when I don't think you're going to be able to remove the ryegrass with Verdict unless you can have tried and you've proven otherwise, but we're probably going to have cross resistance there, which is going to prevent the Verdict from working very well. So it's more than likely a case of you've got resistant ryegrass there, and that is going to be, you're going to have to recognise that as your plant of choice now, and and just live with it. Put the Medic in with it, and it should perform very similar to the non-resistant ryegrass that we were working with. I would potentially in time you might without crossing or whatever, the resistance might diminish. Who knows? But you might be onto a start there where you don't actually have to seed any ryegrass. So enjoy the benefits.
What is the general lifespan of a well-established cover crop with annuals? How long before having to reseed?
Well, we don't have in the vineyard situation anything to act as a benchmark to provide that sort of information, unfortunately. But we do have the dryland farmers out there who have been using these similar sort of pasture species for a very long time. And there's nothing to say they won't still be there in 20 or 30 years' time. I did suggest early on that not in some years you may not get them growing away as you'd like to see due to seasonal conditions or insects or whatever it might be. But I would like to think though that once you have these well established and have they've provided benefit in at least 1 year, that there's still going to be considerable stocks of nitrogen in the soil. There's going to be some improvement in organic matter. There's still going to be some of those root channels in the soil. And so you are still likely to see, as they do with compost application, you're likely to see benefits from the medics and the ryegrass and so on for some years to come, even without those plants actively growing. But going back to your question, I think once they're established, they should be there for a very long time, just regenerating of their own accord. And that's the beauty of them, putting them in once and letting them go. So it really amortizes the cost down to very, very little.
Can you speak to the impact that it might have on vine vigour, Chris?
Yeah, and so vine vigour we have measured with pruning weights, and certainly with the annuals, again, the vine vigour was not suppressed by the annuals at all. And so ratios of pruning weights to fruit weights, they were maintained pretty much throughout the different treatments. So as we, with those perennials that we had, our pruning weights came down considerably, but so did our fruit weights, and so the pruning weight to fruit weight ratio was maintained pretty much. And at the higher ends where the medics were performing really well, and the fruit yields were also very high, and the pruning weights were high, the fruit weight to pruning weight was also pretty consistent. So no, amazingly enough, despite that suppression in soil moisture availability at flowering time, our vine vigour was not suppressed by the annuals, but it certainly was by the perennials.
Why doesn't an annual cover crop have the same benefits as a perennial grasses?
I think it's the other way around, as in the real benefits have come from the annual cover crop, not the perennial cover crop. Certainly in yields in particular, we did get increases in soil carbon. The higher soil carbon levels came from the perennial legume and fescue grass, so strawberry clover and fescue mixed together, which were growing 12 months of the year. And so I guess we can expect that to be fantastic for the soil carbon levels. But otherwise, though, the real benefits came in vine productivity, but also in things like soil carbon as well, and certainly in financial benefits and capacity to compete against weeds and so on, came from those annual legumes and grasses mixed together.
Where legumes were used as a cover crop, did you notice any increase in yeast available nitrogen in juice?
Yes, interesting that one. In 1 year we had a perfect correlation between yeast available nitrogen and nitrogen content in the petioles, which was quite extraordinary. So I think that was in 2015-16 from memory. In 2016-17 there was certainly not much correlation at all. But I mean, I think with some of the other work with yeast available nitrogen, we have seen increases in it as a result of the legumes. And I guess that might have at times undesirable consequences, particularly for the red wines. But there's nothing really conclusive on that at the moment. I really have to go back to the final report just to get more information on that. But please access it yourself, and that does have the information there too.
Have you compared with dryland situations? Were there any differences with cultivars?
Dryland viticulture?
I think that's what he might be getting at, yeah.
Right. So all of these sites have been irrigated. We haven't done any work in a dry grown vineyard at all. That's coming up. We look to be sowing one next year. We've got some very old vines there, which they're keen to see some undervine cover crop on. Because the annuals are not competing over that summer period with the vines, I would like to think that with a dry grown vineyard, which is probably got a root architecture, which is looking at deeper soil moisture than what an irrigated vineyard is going to have anyway, that the addition of these cover crops to that undervine sown is hopefully not going to have too much of a detrimental impact there. It'd be very interesting to find out from your perspective. I'd be more than happy to have a chat about it if you're willing to have a go. And we'll certainly be having a try at it next year as well to see what the impact is there.
Do you have any suggestions for a high rainfall zone, a relatively high rainfall zone, in regards to cover crop choice for the summer season to compete with vines?
So I'm guessing from the question that you have excess vigor over the summer period and in a high rainfall zone. So I mean, I really like to see the wallaby grass in there. It seems to have worked pretty effectively, and it does compete well with weeds over the summer period as well when it's reasonably active. It's not so good over winter. And also, I mean, the cocksfoot is going to be certainly utilising quite an amount of moisture and suppressing an amount of that vigor for places where vigor is an issue for you. So, I mean, that's one way of tackling it. If you're looking to go to the undervine zone, you can also accomplish similar sorts of outcomes with the mid-row as well to suppress vigor there with some of the perennials growing in that environment too. and dragging down the available water supply. So perennial ryegrasses, I'll be cautious about fescues. That cocksfoot, which we described, is going to respond to moisture availability. If there's not the available moisture there, it will die off. If there is, it will keep growing. So that could work fairly well. That'll be a good start anyway, I think. But it's a bit hard to be too prescriptive without knowing your particular situation.
Okay, we'll make this the final question because we've had an awful lot, and Chris has been very kind to sit through all these questions. Can you please comment on using sheep in conjunction with this method, including grazing during growing season with muzzles?
Love the question. And yeah, it makes so much good sense in many ways. We've got sheep prices that are through the roof at the moment, and we've got a vineyard floor which can very effectively provide a lot of nutrition for sheep over certainly winter and spring period and so on. It depends once again on where you are. I have seen some very good examples of sheep grazing in the Riverland region where trellises are higher, and they are grazing there 12 months of the year, and grazing down medics and so on, which are growing underneath the vines, and it's quite a fantastic system to watch. The only time that they are interested in the grapes, and this example which I've seen is post veraison, when they get sweet enough for the sheep to enjoy. They will nibble away on any low-growing canes and take the leaves off them, but otherwise not a problem. Otherwise, in many of our other vineyards, we can't do that, and this idea of the muzzles on sheep is certainly an interesting one. I think it's potentially a great innovation for growers to be looking at, to be able to extend that grazing season through the active growing season of the vines as well. I mean, weeds are a considerable issue, and if we're going to be serious about suppressing the need for herbicides, we've got to look at all options. What we've done with the undervine cover cropping, if we can get them growing and established well, they don't seem to need that. They, as we suggested before, they just mulch down, and there's very little in the way of weed growth there. Having a few sheep running in the vineyards where that has been done could work really well. They could just come through and nibble off any actively growing weeds if they are palatable ones. Things like nightshade and so on might not be so good, but otherwise, yeah, I mean, that could be all very complementary. I think it's potentially a really good way to go to be able to reduce our herbicide inputs.
Okay, I think we'll leave it there, Chris. Thank you very much for answering all those questions. Obviously a lot of interest out there on this topic. If you wouldn't mind just flicking through to that final slide for me though, Chris, and we'll do a quick wrap up. So a big thank you to Chris for providing the content for what's been a really informative session and running through the results of what turns out to be a very promising looking trial. As he mentioned, the final report is available from the Wine Australia website, and I will include a link to this in a follow-up email that you'll receive tomorrow. Within that email, you will also receive a link to the recording for the session. The next AWRI webinar is on Thursday, the 8th of November. The AWRI's Kerry De Garris will be providing some practical information for growers around salinity in soil and fruit. So if you'd like to register for this session and you haven't done so already, please visit the AWRI website. Thank you again for participating, and I look forward to seeing you at the next AWRI webinar.